Hey everyone, today we are going to solve the problem of the day for 25th July 2024, which is sort an array. So we are given an integer array nums and we want to sort it in ascending order and return it. And we should not use the built-in sort function, and the time complexity should be n log n. So one of the easier algorithms to do this is a merge sort. So what is merge sort basically? We try to split a problem into sub-problems till it is smaller in size. And then we can start to solve them. So in this case, like we are given this array, we split it in two halves, keep splitting it till the size of the array is 1. Then onwards, we can start merging them. Now while merging, we have to take care, like we are merging these two arrays, we have to take care that while merging, the smaller element should be inserted in the output first and the larger should become in greater. So I think that's only demonstrable here, that when we have one pointer on 5 and one pointer on 1, we'll push one onto our answer, then move the pointer to next one, then move this one to our answer, then the pointer will go out of bounds and we'll push the remaining array of here. So this will make sure that this array is in sorted order. Similarly, this array is also in sorted order, and then we can recursively apply the same algorithm here to generate our output, which is basically our complete sorted array. So going on to the code. Okay, so this will require me to slice this array in two parts recursively. So slicing is much easier inside Python, so I'll be switching over to Python for this problem. Yeah. So we want to just simply return the merge sort operation performed on nums. We'll have to define that. We'll define merge sort on nums. So sorry. Yeah. So what is merge sort? As you can see in the diagram, we have this array. We want to apply the same algorithm on the left and the right. So recursive sub problems. So we'll do that. First, we'll have to find the mid of it, right? So we'll do it like this. Mid is equal to length of nums by 2. Then we'll apply the same solution on it. Yeah, from starting to mid, and same algorithm on it from mid to end. So we are practically doing this splitting here. So after we have done the splitting, when do we know that we have to start merging? So if length of num double equal to 1, we can return nums. So we have a size 1 array here. So this merge sort will return us the left half, and this merge sort will return us the right half basically. And these will be sorted. As we know that till we go to here, we are splitting and then we are merging. So once we are merging these arrays, we know this is sorted and we know this is also sorted. Then we can go on merging, knowing that our left half and right half both are going to be sorted. So I'll just perform merge on it and we'll return actually that. We'll return the merge of left half and right half. So let's write the merge function. So I'll define merge. We have the left half and right half. So we'll need two iterators and then a result to do this. So result is this. So result will be sorted. We'll need two iterators. So I'll call them I and j. Both are 0 for now. Then I'll say while I is less than length of left half and j is less than length of right half. What we want to do is we want to check which one is lesser. So if left half of I is less than right half of j, we want to push result dot append. Which one is the smaller? The left half. So left half of I. And we'll increment I because we are pushed that. Else, if right half is smaller or equal, we'll append it right half of j, and we'll do j plus equal to 1. Okay. Once we have done that, I'll show it here. So like in action, how it would look like is, let's say this is our I pointer and this is our j pointer. So what we are going to do is the smaller one, 0, we're going to push on to answer. So we'll have this array right now. Then we'll move this to the next one. We'll compare these two. 0 is still smaller. We'll push that to 2. Then we'll check 1 and 2. 1 is smaller. So we'll push 1 here. Then move on to next. Then 1 and 2. 1 is still smaller. We push 1. 5 and 2. 2 is smaller. So we push that and this goes out of bounds. So once this goes out of bounds, what should we do? This array is still remaining. We only have this much part. So what we'll do is we'll check while I is less than length of left half. We are going to result dot append left half of I and I plus equal to 1. And the same issue can occur if, let's say, in this case, yeah, it can happen. If this was triple 1, then 2 will be remaining and this will go out of bounds. Then in that case, to handle that case, we have to write the similar logic for right half. So while j is less than right half length, we push the jth element and j plus equal to 1. So in in Python, the easier way to do is we can simply check the length of left half. So if length of left half, we can do result plus equal to and the left half of I2 till the end. Similarly for j, if length of right half, we do result plus equal to right half of j to the end. So this is a easier syntax which basically Python allows us to write. When we have the result, we can return the result. So that should be it for the solution, I guess. Yeah, it's working. Let's submit this. Yeah, it beat 60%, so quite efficient, I think. Uh, I'll explain the time complexity of it for now. So why is it? We know that it's n log n. Like if you look at the code, it's harder to explain then. So I'll explain it from the diagram only. So why is it n log n? So at each level, let's say that one splitting operation and one merging operation, it takes the takes time of the length of the array we are splitting or merging, which is true basically. So if you look here, if you want to merge these two elements, how many iterations will be there? I'll have to iterate over this element, this element. Similarly, if I have to merge these two, we saw that we did 6 iterations. Either ways, either way you cut it, you have to do n number of iterations. So if you observe closely, at each level, at this level, in splitting this, it takes n time, which is the length of our array. So I'll place it here for explanation. So it takes n time here. Similarly, splitting this, it takes n time again. Then it takes n time again at this level. Same story. N time again at this level. Then for merging also, we know that it takes n time. takes n time, the last two levels also. So that took the merging and splitting both took n times. Then how is the time complexity n log n? Because if you look at that, how many times do you have to merge or how many times you have to split, you'll find that it is roughly the value of log n. So that's the concept of log, right? We keep dividing by the base till we reach 1. So that's what we are doing here. We are having an n-sized array. If we divide by 2, we'll have two 3-sized arrays similarly. So if we have an 8-sized array, I can predictively say that depth of this half, this tree, is going to be a log n, which is 3. Similarly, for merging, it's going to be 3. So it's 2 log n in actuality, but we can ignore the constant. So the overall time complexity comes out as n log n because we are doing comparing n elements log n number of times or 2 log n number of times. So yeah, that is the basically time complexity analysis of merge sort. And that is also the space complexity analysis. At each phase, we know that we are dividing it into two parts and each part is consuming some space. So yeah, that was it. Thank you.